8.7. A block whose mass is 1 kg is fastened to a spring. The spring has a spring constant of 50 Newton per meter. The block is pulled to a distance x is equal to 10 centimeters from its equilibrium position, x is equal to 0 on a frictionless surface from rest at t is equal to 0. Calculate the kinetic and potential and total energies of the block when it is 5 centimeters away from the mean position. Okay, so here we have a one block and which mass is 1 kg fastened to a spring, and the spring has a spring constant of k, that is 50 Newton meter. Okay, so mass of the block m is 1 kg, and spring constant is also given that k is equal to 50 Newton per meter, and the block is pulled to a distance x is equal to 10 centimeters from its equilibrium position, x is equal to 0, means that x is equal to 10 centimeters is a maximum displacement from its mean position. So it is called as amplitude, that is equal to 10 centimeters, and which is equal to in meters, that is um, 0.1. So it is equal to 0.1 meters. Okay, so this is the data is given here, and by this we can calculate the uh, kinetic energy, potential energy, and total energy when the block is at 5 centimeters away from the mean position. Okay, so for suppose this is our spring and block system. Okay, so it is our equilibrium position. So this is our equilibrium position, x is equal to 0, and the maximum displacement is also given, that is x is equal to 10 centimeters. This is our maximum displacement, and also which is called here amplitude, that is a. But now we have to find out the kinetic energy and potential energy or total energy when the block is at x is equal to 5 centimeters. Okay, means middle of the that oscillation. Okay, so according to this question, that first we have to find out the what is the kinetic energy and potential energy in this case. Okay, so the frequency of the spring is given by, that is omega, sorry, the frequency means angular frequency is given by omega, that is equal to under the root of k by m in case of a spring and block system. That is omega is equal to under the root of k is equal to 50, and mass m is equal to 1. Okay, sorry. Okay, that is 50 by 1. Okay, so then after solving this, we got this is equal to 7.07 radians per second. So omega is equal to 7.07 radians per second. This is the frequency. Now displacement at any time, we know the formula. It is x of t is equal to a cos omega t plus pi. This is our formula at any time. Then write this. Now we have to find out the a question a, that is displacement. displacement at x is equal to 5 centimeters away from the mean position. Displacement, sorry, yes, displacement at x is equal to 5 centimeters away from mean position. Mean position, and that is equal to, so according to our formula, x of t is equal to, that is x of t is equal to a cos omega t plus pi. So from it, pi is not given, so we have to take only up to omega t. Okay, so this is equal to x of t. X is equal to nothing but here 5 centimeters. So x is equal to 5 centimeters. That is, if you are converting into meters, that is equal to 0.05 meters. Okay, so which is equal to a. A is the amplitude, that is equal to how much? 0.1 meters. Cos of omega t. Omega is equal to, that is 7.07, and t is t. T is not given here. Okay, so then this is our equation. So from this we can write, that is cos, this 0.1 I am taking to this side, that is 0, sorry, cos of 7.07 t is equal to 0.05 by 0.1, and it is equal to 0.5. This is our cos 7.07 t is equal to. Okay, so from this we can write, that is sine of 7.07 t also, because we will use it later. So for that we got, it is that is root 3 by 2 value. Okay, so this is our cos 7.07 t is equal to 0.5 from this equation, and by using this we are getting, that is sine 7.07 t is equal to root 3 by 2 by taking the right angle triangle like this. Okay, so there it is, the angle is this one, that is 707 t. It is the angle like our omega t. So according to cos, the 0.5 by 1. Okay, so cos is nothing but adjacent side by hypotenuse. Okay, so that's why adjacent side is here 0.5, and hypotenuse it is equal to 1. So if you are writing the sine equal to sine theta is equal to, that is opposite side by adjacent side. That opposite side is um, by what we call here, it is by Pythagoras law we can find out this one, that is equal to 1 square is equal to 0.5 square, and it is an unknown quantity, plus that is x square, that is x square is equal to this is 1 square minus 0.5 square, and it is under the root, x is equal to, and that is equal to 1 minus 1 by 2 square. So from that we got, it is root 3 by 2. Okay, so you can do that. I don't have sufficient space here, so from that, sine theta is equal to, you got it, root 3 by 2. So this is what our position. Okay, so then sorry, cos 7.07 t is equal to 0.5, sine 70.70 is equal to root 3 by 2. At x is equal to 5 centimeters, this is our equation. Okay, So the next velocity. Okay, so velocity at x is equal to 5 centimeters. Okay, this is our important one because we have to find out the kinetic energy and potential energy at this what mm, at this distance. Okay, so that's why now we have to find out the velocity at this position, that is x is equal to 5 centimeters, and we have a formula for velocity. V is equal to minus a omega cos omega, sorry, a omega sin omega t, a omega sin omega t. This is our uh, equation for the velocity in simple harmonic motion. So write down here magnitude of the velocity, that is v is equal to a is equal to, that is equal to 0.1, it is 0.1 into omega, omega is equal to, we got here, that is 7.07 into sin omega t. Sin omega t means here, that is sine of omega means 7.07 time is t. So then that is equal to 0.1 into 7.07 into sin omega t, that is equal to root 3 by 2. Okay, that's why we have to calculate here. Okay, so this is root 3 by 2, and this root 3 by 2 is equal to also 0.1 into 7.07 into, this is 0.866, and after solving all this we got it 0.61, 0.61 meter per second. This is the velocity at x is equal to uh, 5 centimeters. Then find out the kinetic energy. We got the velocity, what? A velocity. Then find out the kinetic energy. So kinetic energy at x is equal to 5 centimeters. That is equal to, kinetic energy is equal to half into v square, half into m into v square, half into m into v square, and that is equal to half into m. M is equal to 1, mass of the block is 1, and v is 0.61 whole square. This is 0.61, and it is equal to, after solving this all, we are getting 0.19 joules. This is the kinetic energy at x is equal to 5 centimeters. Then potential energy of the block. So potential energy is equal to, half into k into x square in case of spring and block system. Okay, so this is, we can write here, it is equal to half into k. K is equal to, already we got here something, that is 50 Newton meter per Newton meter. So that is 50 into x. X is equal to position. So that position we got here. So already the given position is equal to, that is 5 centimeters. 5 centimeters means it is in meters. We have to take in meters. That is 0.05 whole square. So that is equal to half into 50 into 0.5, 0.05 into 0.05. So it is equal to, this is 0.05 into 0.05, and after multiplication of this all, we got it is equal to 0.0625, 0.0625 joules. This is the potential energy. Then total energy. Okay, total energy at x is equal to 5 centimeters. That is, total energy is equal to potential energy plus kinetic energy, and that is equal to, this is potential energy is 0.0625 joules plus this is kinetic energy is 0.19 joules, and total it is equal to 0.25 joules. This is the total energy at x is equal to 5 centimeters.